Thank you so much for the invitation. It's such a pleasure to be here and to be speaking to you all. I do have a request. Do you think we could lower the lights a little bit on the stage? Awesome, thank you. It's gonna be better for the visualizations, I can assure you. So I'm going to be talking about a range of projects, obviously data visualization projects. And I hope that by the end you share the excitement that I do around data visualization really as a medium. You can use it for scientific insight, you can use it for art, you can use it for communication, and so it speaks all sorts of different languages. I also want to say that all the work that I'm going to present here, it's not work I've done just by myself. This is work that I've done with my longtime collaborator, colleague, Martin Wattenberg, who's sitting right here. So I have to deliver a good talk, and so let's get started. So Martin and I have been at Google for 7 years now, but even before joining Google, we were looking at data that Google puts out, and one of the questions we asked ourselves is Google kind of an oracle? You know, when you start typing something on Google and it starts to give you options of how to finish your query. Why do you think Google does that? I type why, and it says, why is the sky blue? Why? What? Any questions about, any guesses about why Google does that? Makes your life easier. It's about utility, right? Google is trying to highlight for you the most popular, most likely endings to your string, to your query string. So that's a very utilitarian way of thinking about data. But Martin and I thought about that, and we thought, those completions there, those are also an interesting way to peek into the collective psyche and ask, what are people coming to Google for, and what are they asking Google? So we decided to do a visualization of that kind of data. And so what I want to show you now is this piece we did called the Web Seer. So I'm just visualizing the data that Google would show you. And I'm saying, will he? And Google is asking me, will he come back? Will he miss me? Will he text me back? and so forth. And I can pair that, because I'm visualizing it, I can pair it against another query. So I'm gonna say, will he versus will she? And then the visualization will show you how they overlap and how they are not the same, okay? So this is a really interesting exercise, and it ranges from really funny to kind of interesting. So I can say, is my husband versus is my wife? And or I can say, is my son versus is my daughter? And again, right, you start to see it, as I said, it ranges from the funny to the kind of depressing. And to me, it's really, sometimes I can feel it in the gut. I'm like, wow, these people are coming to Google asking these very serious, deep questions and hoping to get answers. And I think one of the things that a data visualization can do like this is to start to talk to you at an emotional level too. Because you are thinking, wow, these are parents going to Google and trying to understand what is happening to their kids. Don't worry, it's not all depressing. So you can say our cats versus our dogs. You know, you can actually switch that around and say cats are versus dogs are, and you can see it's good. So there is hope. There is hope. This, by the way, is public. you can all play. Don't play with it right now. Pay attention. There's more interesting demos, but it's called the Web Seer, and it's public, and you can go play at your heart's content. But one of the things I want to talk about is data visualization for scientific insight. So, and this is literally the first project Martin and I worked on together. It's called History Flow, and it was in the beginning days of Wikipedia, where we had to explain to people what a wiki was and how it worked and how come it worked at all. And so we were interested in visualizing the evolution of Wikipedia articles, okay? And so this is back in 2003, so now you know how long I've been working together with Martin. And obviously, this is vintage images, so admire vintage internet and web. But we would find articles like this on chocolate. And then we noticed that each article had a log of its edits, okay? And we're like, oh, this is the data we can visualize. This is where the ins and outs of an article are. And each one of these edits has a timestamp. It also has an author. They can leave comments if they choose to kind of explain what they did. And so how do you visualize this? So what we did is we decided to give each author a color, okay? And let's say that, so I have Mary in orange, Suzanne in blue, and Martin in green. And let's say that Mary started the first version. So the length of my line is the length of the article, okay? And so Mary started the first version. Then on the second version, Suzanne added a little paragraph at the end. So you can see the little blue at the end. So not only does length matter, the location of my line matters, okay? On version 3, the article became shorter because Martin deleted things and inserted a little thing there, okay? So that's how this visualization works. To make things even more obvious, what we did is we connected segments of text that stay the same from version to version. So you end up with these polygons. You also end up with these holes here for insertions and deletions, okay? And then once I have this structure, I can play with it. So right now I am showing each version equidistantly, okay? But I can also show it in real time. And so I can see that there was a lot of time between version 1 and version 2, but then version 3 came right after it. Okay, so I can start to get a sense of rhythm. Another thing I can do is I can highlight any of the versions and I can show the actual text, and I can then color that text by its author, all right? So we came up with a technique and we had no idea what Wikipedia looked like. So let me actually start showing you what Wikipedia looked like back in 2003, okay? So this is the history flow diagram for the evolution of the article on design. I have my wand here at the top that I'm playing with. In the middle, you can see. On the left, I have the list of authors who have touched this article. And on the right, I have the text of the article itself. Okay, so design looks like this. Now let's look at something a little bit more internet friendly, cat, the article on cat. So immediately I can see that I have a lot more versions. I also have a lot more authors who seem to care about cats than design. It's a much longer article, so I'm scrolling down. It's all good. And then I can see things like, oh, there's a stripy pattern here at the top right. What is that about? So if I come all the way here where the stripy pattern starts, I can see that there is a table that got added with, oh, you know, what is the class of cats and order and species and, you know, so forth. And it remains untouched. I can also see another interesting thing. There is something poking out here at the bottom that looks like an antenna, and nothing gets connected to that. So what is going on there? So if I bring my wand to this, I can see that a bunch of paragraphs got added here about the computer command called Cat in Unix, okay? So I thought this would resonate with you. What happens afterwards? It just disappears. If I go to the next version, does it just disappear? No, it gets redirected into a brand new page called Cat Unix. Okay, so this is exactly the kind of collaborative dynamic we were trying to uncover with this kind of visualization. How are people coming together and deciding what fits and what doesn't fit in any of these articles? So now let's take a look at something a little bit more controversial. This is the article on abortion. What do you see here that is different? Anyone? Yes. Wholesale deletion. Yes. You already gave the punchline. Yes. You have these black gashes, right? You are right. It's absolutely right. So I have this really long abortion article, but then here, boom, it's gone. Someone completely deleted it. Okay. Or over here, someone deleted and said abortion is great, and then they came back and said abortion is good. Okay. So this is vandalism. There's a name for it in Wikipedia. It's called mass deletion. Okay. But it gets fixed. And not only does it get fixed, let's look at when this first deletion happened. I have the timestamp at the bottom. Don't know if you can see it. This deletion happened on the 17th of December at 4:06. Okay. It got fixed on the same day at 4:07. Within a minute. And this is something we started seeing over and over again. In fact, if I visualize the same data, not by versions, but by real time, you never see these deletions, okay? So we actually got in touch with Wikipedians. We're like, how are you doing this? How can you fix stuff in minutes? That's when they told us about something called a watch list, where when you edit Wikipedia, you can create your own watch list, which is a list of articles you care about. When someone edits those articles, you get a notification. Multiple people are watching the same article. If you know and trust the username of someone, you may not care to look. But if it's a new IP address or an anonymous user you've never seen before, you might want to go and check and see if this is something you need to take care of. All right, and so to finalize this demo, I'm going to visualize our favorite page, which is obviously chocolate. And in real time, it doesn't look like much, except that it's pink. But if I do it by versions, I have this interesting pattern that looks kind of cool. Does anyone want to guess what this is? The zigzag.
Two authors, one's deleting, one's
Yes, 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 exactly. It's a fight. It's a beautiful fight. It's an edit war, okay? And I can show you how it goes. So back over here, all the way here, someone added this little paragraph in white. Oh, sorry, I'm looking at the wrong thing. Here. This little paragraph here in white, okay? Daniel C. Boyer added this paragraph that is in white here. I'll read it for you. Extremely rarely, melted chocolate has been used to make a kind of surrealist sculpture called collage, okay? This survives for all of this time. And then someone comes here and says, removing Boyer invention. Well, he comes back and says, reverting, collage is not a Boyer invention. Google search for chocolate collage finds only Boyer. Reverting, leave your humbug out. Reverting, and so forth. Until Daniel C. Boyer gives up, which is unfortunate because Martin and I did a search for chocolate collage, and it is a thing. But such is life in Wikipedia. Sometimes you don't win every battle. But again, this was another one of those collaborative dynamics that just became clear in this kind of diagram. Another thing we did was to get rid of all the colors of the authors and just visualize the age of the text. So the darker a piece of text is, the older it is. Why do I care about that? I care about that because age of text, in this case, could serve as a proxy for text quality. If you have a ton of eyes looking at the same page and they're not bothering to touch your text, chances are the community thinks it's high quality text, okay? And the good news is that there was quite a significant amount of kind of older, untouched text. Another thing, just because this is a data science conference, another thing that Martin and I did, so we created the visualization, we were visualizing and seeing these patterns, but we weren't sure how general these patterns were, because we're like, oh, chocolate, let's visualize chocolate. Oh, abortion, let's visualize abortion. So what we did, in addition to visualizing, is we downloaded all of Wikipedia and we ran a statistical analysis on things like how long on average does it take Wikipedians to revert mass deletions, okay? And so the good news was that on average in Wikipedia, back in 2004, it was taking around a couple of minutes for mass deletions to be reverted. So again, one of the things that I think is a good thing to keep in mind from a data science perspective is this complementarity between data visualization, where you don't necessarily have a specific question you're asking, but it shows you an overview. And then once you have a very piercing question, can you then go back to statistics and run a statistical analysis that will tell you, oh, am I seeing the big picture? Is this, how well does this hold? All right. Now I want to talk about some more recent things. So this is our group at Google. Everything I showed you so far was not Google. This is our group at Google. Martin is here at the bottom left. And we have an awesome team. And so I want to talk a little bit. We are part of Google Brain, which is ground zero for machine learning. And so we're doing a lot of what we do is how do you use data visualization in machine learning contexts. And so I'll show you a couple of projects along those lines. As was mentioned before, I also co-lead the PAIR initiative, People+AI Research initiative. And this is the idea that if, as machine learning becomes more ubiquitous around our society, you want to be thinking and creating machine learning systems that are human-centric, where you are thinking about user needs from the beginning and user tasks, and you're designing those into your objective functions. And so that's a lot of what the research we do at PAIR is about. All right, so can visualization help in machine learning? You bet, it's all about data, right? So there are multiple ways in which we can be helpful. The thing I want to highlight today is this notion of model understanding. So in other words, interpretability. And I'm going to talk about a specific kind of data space, if you will, in terms of model understanding. And this is high dimensional space. So very quickly, we're going to do a warm-up exercise here, where I'm showing you one of the Hello World data sets of machine learning. It's called MNIST, and it's nothing more than handwritten digits. And the whole point of this is to teach a computer to tell the zeros apart from the sevens, apart from the eights, no matter how bad your handwriting is, okay? So it's a hard task. How do we do this? A lot of times we transform images into vectors. How do we do that? We look at each pixel of the image, and I will care deeply about the color of that pixel. So if I find a pixel that's black, I give it a value of 0. If I find a pixel that's white, I give it a value of 1. And if I find a gray pixel, I give it a value in between. I do that for every pixel in the image, and I end up with a vector, okay? So what I've done is I've turned this image into a vector. It's a vector of 784 pixels, 784 dimensions, because I have 784 pixels. Very straightforward. What does this get me? It gets me into the world of math. And that's good news for me, because it means that all of a sudden I have a mathematical way of telling the distance between these images. okay? Because now I have a bunch of vectors and I can compare them. So the thing I want to show you is this visualization that looks into these spaces. A high-dimensional space in machine learning a lot of times can be thought of as an embedding space, and so I'm going to be talking about it that way. So we created this visualization called the Embedding Projector, and it's open source. You can use it, you can download it, you can fork it, you can make it better. And the whole idea is to find projections for high-dimensional data. So now I have my MNIST data set, and I've run, in this case, a principal component analysis, a PCA projection onto this, okay? We have multiple projections here. I'll show you a couple. But just doing PCA already, I can tell that the zeros seem to be clustering together, right? And I can come and interact with this thing, and I can be like, oh yeah, that's where the sevens are. I can also do another trick, which is, this is data that has been human labeled, so I have ground truth. Someone has said, yes, this is a 7, this is a 0. And so what I can do is I can color by those, by the ground truth. And that helps me understand how well these things are clustering or not clustering. Okay, so again, my zeros are doing pretty well here. In fact, if I click on one of them, the visualization shows me the nearest neighbors, okay? So I can get a sense of how tightly clustered they are or not. Another thing I can do is I can use a different projection technique. I can use for the same data, I can use something called t-SNE. t-SNE is a non-linear way of projecting and high-dimensional space, and it does a better job of keeping tight clusters together. It's not very good with the overall global structure, but the clusters it tries to do a good job on. And so the good news for me is that my clusters, there's quite a lot of white space, if you will, between these clusters, which is good. I can also see interesting things like, oh, this cluster of 1s here. It has an interesting shape. And if we look at this, it turns out that the ones at the bottom here are kind of slanting to the left. They become straight up, and then they go and slant to the right. And again, I'm not telling the computer to do anything. It's just comparing those vectors. But it gets the subtlety, right, in the slanting of the numbers. So this is all great. And as I said, it's a hello world example. So now let's talk about a real production system and how to use visualization to understand what the model is doing. Let's talk about translation. Google Translate, okay? Last year, year and a half ago, Google came out with something called the zero-shot translation or multilingual translation systems, where you could input multiple languages and you could translate into multiple languages, which was kind of a feat. Not only that, it had this ability of do what we call zero-shot translation. So in other words, the system would only see data, translation data between, say, English and Japanese, Japanese and English, okay? English and Korean, Korean and English. And somehow, even though it had never seen data in this direction, it would be able to do a good job translating straight from Japanese to Korean, okay? This is what's called zero-shot. The researchers building these models had a very fundamental question, which was, how exactly are these systems doing this? What does the embedding high-dimensional space of these languages look like? Imagine I am coloring each language in my system in a different color. Does it look like the image on the left, where, let's say, English is blue and Korean is green and Japanese is yellow and another? Does it look like separate neighborhoods like this? Or does it look like something here on the right, where these languages are coming together and kind of melding together? Why does that matter? It matters because if my system is doing something like this, it might be paying attention to the meaning of the word more than it's paying attention to the language. So in other words, the fact that I have a string that says home and a string that says casa, somehow my system knows these mean the same thing, except even though the strings are very different, right? That would be the system on the right. So what did we do? We decided to visualize this space. Imagine we have a sentence like the stratosphere extends from 10 kilometers to 50 kilometers in altitude. What does that look like in embedding space? It might look like a bunch of dots, okay? And what I will do is I will connect these dots. That's what my sentence looks like. Again, the question becomes, okay, that's great, that's a sentence in English. When I translate that sentence, does it look like something like this, where the English is hanging out to the left and the Portuguese version is hanging out to the right? Or does it look like more like something like this, where the two languages are coming together and clustering? Okay, so now for the big reveal, let's go back to the embedding projector and show you this. So this is a visualization of a multilingual system with 3 languages. It's Japanese, Korean, and English. Each one of the languages is visualized in a different color, okay? So just by looking at this, given how I told you the colors work, do you see a neighborhood that is all yellow, another neighborhood that is all red? And no, right? Right. So this was the big aha moment for us, because this was the moment when we realized that these systems might be showing the first signs of what we call a universal language, an interlingua, okay? Because again, these things are clustering at the semantic level. It seems like they are, right? In fact, let me see if I can do let me do a search here. Oops. Oops. It's not finding my thing. I want to find the cluster I like so much. Where is that? Oh, is it here? Yes. Okay, the stratosphere. Okay, so this is my cluster. I'm gonna bring it over here about the stratosphere, okay? And I'm going to click out of it. Do you see the 3 colors clustering together here, right? And if I click on it again, the nearest neighbors, I'm highlighting the nearest neighbors, are all in the same cluster. It's also highlighting other things that have numbers as well, okay? But nearest neighbors to my sentence are all the way to the top. So this was a scientific insight. This was something literally that visualization could do that would be really, really hard to do otherwise. The other thing I want to show you before we walk out of this is the fact that we then visualized in the same way a sister model, which was a model that was doing Portuguese, Spanish, and English. Again, same thing. I'm using each language, I'm visualizing in a different color. What do you see that is different here? The red, right? Yes, there's a whole neighborhood there that's red. We talked to the researchers, we're like, what's going on here? We decided to do some, again, statistical analysis of that cluster of sentences there, and we found out that there is a correlation with bad quality translations, okay? So the fact that you have this entire neighborhood of a single pair of languages, in this case it's Portuguese to Spanish, okay? And they're not clustering with anything else in the system, that's a bad sign. Because again, it's telling me the geometry of this space matters. And so if your system looks something like this, it's probably not doing the right thing, okay? So again, 2 similar systems, and you could see how this high dimensional space could give you a lot of clues into debugging, right? All right, the final thing I wanna end with is this notion, as I said, data visualization to me is this medium, and we can do many different things. So one of the things that Martin and I have done is to think about data from an artistic perspective, and data visualization from an artistic perspective. So I want to talk about a couple of projects there. One is a few years ago, many years I think now, Boston Magazine came to us and said, can you visualize the city of Boston? And guess what? It's not interactive, it's a print piece, it's on a magazine. How do you visualize a city? So we started thinking about this, and we thought about Boston. And unlike California, Boston gets cold, and it has seasons that are very, very well marked. So we're like, oh, is there anything we can figure out about the way colors change in the city? So what we did is we went to Flickr. Am I okay? Okay, all right. We went to Flickr and we downloaded all the public photos that were under creative license of the biggest park in Boston. It's called the Boston Commons. It's kind of like the Central Park of Boston. And our hope, we didn't know if this would work, but our hope was that by downloading all of these images for a whole year, and binning the images. Oh, these are all the photos for January. These are all the photos for February. These are all that somehow we could capture a change in color, okay? So that's what we did. And then after we had all these images and we binned them by months, we went back to our color cube, and literally what we did is we started counting pixels. We started counting pixels and putting those counts into each one of these color hues, okay? And then we decided we created a visualization that showed these colors for a whole year. And so this is the visualization. And to our delight, it does turn out that colors do change, which was awesome. And so what you can see at the bottom there is January, with lots of whites and grays because it's Boston. And then if you go clockwise and you go up towards May and June, you see a little bit of like a magenta fuchsia color. Those are the flowers starting to bloom in the park. And then you have a big bulge of green there approaching summer. And then obviously towards October and November, you have all of these earthy tones. Okay. Another thing, because this is very flowy, it might not a lot of times be obvious just how much the distribution of colors changes. So we also did this little thing where we actually cut the most dramatic pieces for each season, and you can see how much the distribution changes. So again, using data to just give you a fresh perspective on something that, you know, it's your city. You kind of look at it every day. I want to end on this other project we did called the wind map. And this is something that Martin and I did where we were trying to visualize the invisible, which is how do you visualize wind? And the truth is wind had been visualized for hundreds of years. And interestingly, most of the visualizations tended to be static. And they also tended to average a lot of the data. So you have these vector fields, right? And you aggregate a lot of data and you try to show what's happening. What we wanted, after lots of experimentation, we have a whole talk on the wind map, just talking about dead ends, like how many different things we tried that didn't work. Eventually, we got to the wind map. So this is the live wind map. And we decided it was important for us that it be dynamic, just like the wind. This is real time. You can do things like, of course I'm doing Boston. I'm not in Boston today. Let's not do Boston. Let's come over here. Oops. You guys get a really cool part of the country because there's all this tracery with the mountains and everything. And there were a couple of decisions we made here. One is that we really wanted to focus on the shape of the wind and not show state lines, because the whole point was to let things flow here. We didn't use color. It's the only visualization we have that does not use color. But obviously, we're using brightness in specific ways here. Another thing that was really interesting to us was just how much the wind changes day to day. And so we have something where we have a gallery of actually, let me just do it like this. Yeah, of different days of the wind. And so you can go there and you can see days like this where Canada steals the air from the US. And not even the mountains stop that. That's just crazy. You see days like these where this is Hurricane Isaac making landfall. And something interesting started happening when we did the wind map. This is, we did the project in 2012. And because it's a real-time data visualization, one of the things that started happening is whenever there was a hurricane that was making landfall, so for instance, this one, we started getting emails. So one email I remember was someone who was in New Orleans and writing to us and saying, I'm sitting here, I'm looking at your visualization, I'm praying that this thing goes past us. And it was a very, another one of those moments of like, oh wow, this is obviously really powerful. I hope everything is okay over there. It wasn't until this happened, Martin and I were in the path. And so this is Sandy. And we were in the same situation and hoping that things would be okay. But one of the things that I think is really interesting to think about from a data perspective, from visualization perspective, is that the data we have here and the data we have here is exactly the same, okay? One of the things we're not doing here is we're not averaging the heck out of everything. We're trying to keep as much texture and messiness as we can. And in part, because we're doing that and we're keeping the details, it's easier on your eyes to actually understand the patterns and understand the broad strokes versus the details. And it works nicely, if I may say so. But it's an unintuitive point, right? Because the more texture and detail not necessarily always works. The last thing I want to say is that we started getting a ton of emails from all different kinds of different communities. So turns out farmers look at the wind map before they spray their crops. And we never meant it as a utilitarian piece. Scientists look at the wind map to study bird migration, butterfly migration. Teachers look at the map with their students to try to understand weather forecast patterns. Pilots, we started getting emails from both commercial pilots and military pilots, at which point we're like, no, do not use the wind map. Because we say it very clearly, this is surface wind data. Do not, which means it's up to 12 meters or something. It's not what you want for your flight. And pilots know, but we actually felt compelled to put a disclaimer. This disclaimer is on our webpage. And then after we put the disclaimer, we still got emails like this one saying, yeah, I get it. I see your disclaimer, but please respect the power of this visualization, in this case in promoting prevention of wildfires. A couple of the things that happened with the wind map that were interesting. We put this on the web. We didn't obfuscate our code. We didn't open source it, but we didn't obfuscate. So if you know what you're doing, you know how to get to the code. And it turns out that real professional weathermen use the technique, actually, to show wind. We never thought this would happen. This was amazing. So everybody today uses this kind of visualization technique. Another thing that was really cool was that the wind map is the first web-based art piece to be part of the permanent collection at the MoMA in New York, and it's been in a number of exhibits. And so I want to stop here and just go back to the title, which is, I do think it's this medium for exploration, for communication, for scientific insight, and also to welcome other people into the world of statistics and data. If you're not barraging viewers all the time with equations and tables, if you can speak the visual language, a lot of times it means that you're broadening the debate and that you're welcoming viewers or thinkers who may not think they can think about data, but they can. And so I would love to leave you all with this message and welcome you and hope that you do wonderful things with data visualization. Thank you.
Fernanda, thanks so much. That was terrific. We've got a few minutes for questions, so please stay up there and we'll take some questions. Who'd like to kick us off? With gentleman in the blue shirt there. Yes, please. There should be a mic. There's a couple of mics roving around. If you can wait for the mic and then introduce yourself very briefly and then on with the question. Thank you.
Hi, my name is Ravneet and I'm a student at MIDS here. Thanks for the great presentation.
Thank you.
You touched upon various use cases where visualization helps understand the underlying model, but have you seen any use cases where the visualization itself was used to augment or feed into a new model?
Oh, for machine learning?
Yes.
So one of the things that happens when you have moments like those where we show that this geometry matters is that then you can use that to start debugging your model, right? And then you can start, you're gonna have to go back and either add more training data, whatever helps you to get that model to perform the way you want. But what I would say is the potential biggest impact a lot of times is just to even start to understand what is happening with your model at a very high level, I guess, and then start to poke at it in different ways and hopefully get to a performance that you want.
Thank you.
Mm-hmm.
Okay. Let's take right over here next door. Thank you, and then we'll go.
Hi, Anatoly Nemerk. Thank you so much for the great presentation. Question is, how do you determine what type of visualization to use depending on your audience's sophistication, if you will, or their capacity to understand the images?
I have many answers to that question, so I'll try to summarize. Something happened many years ago. I overheard a conversation between the New York Times, some of the New York Times folks who deals with the New York Times does amazing things with data visualization. And one of the editors was saying, we don't use scatter plots. We just can't, because people just don't understand them. At what point I was very saddened by that comment, because I'm like, if people can't understand scatter plots, we're lost, because what are we going to do? Fast forward many years ahead, I think the good news is the New York Times does use scatter plots today. They have found ways of annotating the graphs so that you can do things like, this quadrant here means X, this other quadrant here. So like walk the viewer a little bit, add bridges into your visualization so that if you have an insight that you want to call attention to, help your viewer get there, right? That's one thing. Another thing that brings me great joy and confidence is the fact that today places like the New York Times are always introducing cutting-edge data visualization techniques to their viewers, who are lay users, if you will. So things like there are some kinds of tree maps or hierarchical visualizations that used to be only in like top academic journals and were things of like experts, for experts, by experts. They are in newspapers today, and people get them. And also interaction also helps, right? Interaction is another way to walk your viewer and help your viewer in getting to the points, to the insights that you hope they will get. So I think annotation is huge, explanation is huge, interaction can be also huge.
Okay, thank you. There's a question in the corner there, and then we'll take another couple.
Hi, this is I'm kind of a linguistic nerd, so I have a question about the translations. I speak Spanish and Portuguese, and I assume you speak Portuguese, right? Do you also speak Spanish? Do you speak Spanish at all too? Do you speak Spanish at all?
I speak Portuñol.
Okay.
I can fake it.
Well, so like I'm always fascinated by a lot of like the similarities and differences between Portuguese and Spanish, and like there are some words that are the exact same word in both languages, but they mean different things, and then there's different structures, but it's like kind of like, you know, similar. And so I'm just really curious if you could dive deeper into like why in the translation it was clustered like that. Cause
yeah. So that's a wonderful question, because that, so yes, I speak Portuguese. That's my native language. And when I heard that there was a multilingual model that did Portuguese, Spanish, and English, I'm like, oh, that's just so easy. It's obviously gonna work. I don't speak Japanese, I don't speak Korean, and I kind of thought, without speaking those two languages, that those languages were just as close together as Portuguese and Spanish. Turns out that is not the case at all. Japanese and Korean, very different languages. So now let's step back and think about that. The model that had Japanese and Korean and English clusters somehow, even though these three languages are extremely far from each other. The model that has Portuguese and Spanish, which are very similar Romance languages, right? And English does not cluster. How in the world? That is completely unintuitive.
Yeah, that's
yeah. So that was part of the mystery. And then, as with many things machine learning based, you go back to your data set and you start looking, do I have enough examples? Do I have enough training data to do that? Is there anything I need to tweak on my features? Yeah. No silver bullet there.
So you don't know is what you're saying?
I don't know why it was.
Yeah, why cluster like that?
I believe it was about data. Is that right, Martin? I think it was about data.
Okay.
Yeah.
So like data integrity, like data like data
not
cleaning?
Enough training data.
Oh, okay.
Yes.
Got it. Okay.
Okay, we've got time for maybe one or two more questions. Gentleman there with the glasses, just right in front. Yes. And then, sir, who's standing up? You'll take the last question. Yes, please.
Thank you. This was a great presentation. I actually believe this is more an art form than the exact science. And my question to you is, what's the process when you like any one of these visualization, right? Like when you decided that this is what I want to do. I'm assuming you probably didn't jump into the data first. There's like the thought process into it. Like, hey, so can you talk a little bit at a high level? Like, what is your process to actually go from a concept to what we saw today?
Yeah, sure. So there are different, with different projects, it might be different, but there's one thing that is common to all of them, which is even when Martin and I might have an idea of what we might want to visualize, as soon as we get the data and we start playing with the data, that's when things start to happening for real. So for instance, with the Wikipedia project, our big dream was to visualize all of Wikipedia. We wanted to create a Wikipedia map. We're like, no, we can't. Then when we found the data about with the logs, we're like, oh, this is the right granularity. Maybe there's something we can do here. That's one example where the data kind of led us. With the wind, as I said, there's a whole talk just about, even though you might look at the wind map today and be like, yeah, that's kind of obvious. Yeah, of course. Yeah, you draw lines, they move. It's kind of like the wind moved. Oh, it took us months of trying different things, of getting stuck, of thinking about color. Does it move? Does it not move? And being very stuck many times. So basically, I think two things. One is follow the data, like pay attention to your data. That's one thing. The other thing is, I think we always feel like we are at a good place, because you're right, it's not a science, right? You have to try things, you have to feel your way through a different data set. But if you get to a point where you feel like your visualization technique is doing a good job of showing you the structure of the data. So like with the WIN, eventually we got to this place where we're like, oh, this thing works for broad, large patterns, and it works for the details too. It doesn't obscure one or the other. That's a good place to be. Another place where we're like, in terms of process, where we're like, oh, we might be getting somewhere. We always talk about this, is a moment when you stop programming and you start playing with the visualization, and you're like, whoa, what does chocolate look like this? What does abortion look like? Wait, no, let's visualize. And you just forget that you're just, now you have a bunch of questions that you didn't even have before. And again, that's, even though it's not a scientific principle, it's a very good sign that you probably hit something that is meaningful.
Thank you.
Mm-hmm.
Okay. Final question, and then we'll move on. Gentleman standing at the back there. Thank you.
Thanks for a beautiful presentation.
Thank you.
I'm wondering, there's been a lot in the popular press recently about the biases, both implicit and explicit within data. To what degree do you see visualization as a way of either exacerbating or mitigating some of the biases that exist within either the models that are built on top of data or the underlying data?
Yeah, thanks for that question. So it turns out that PAIR, I didn't have time to show it today, but one of the visualizations that PAIR has launched and open source is a visualization of training data sets for machine learning. And it has been used specifically also for looking at fairness and biases, because it allows you to visualize the distributions in your data sets. And so you can very clearly see sometimes if there are skews, you can very clearly just see those skews. And we're starting to see people, both researchers, activists, using that visualization. It's called Facets, by the way. If anyone goes to the PAIR website, it's called Facets. We're starting to see that visualization be used exactly for that, both to discover bias and also to communicate about the bias and be like, look, this is, because again, you could communicate to your project manager, you could communicate to an executive, because it's a visualization. It's very welcoming and very easy to see. Hopefully it doesn't augment bias. Hopefully it lets you peek into it and see. Another thing that I'll say about data visualization, it's not necessarily about bias, but somewhat related. Data visualization is amazing for showing you mistakes in your data. You know, the whole data cleaning thing, which I'm sure you all are familiar with. Data visualization it's just like, whoa, what? Nobody looked at this cell before. This cell is at the wrong, so it is a good technique, a good lens to be using.
Great. Please join me in thanking Fernanda.
Thank you.